Relations can be a tricky subject in discrete math because it seems so foreign to mathematics that you are used to. Unfortunately, I've seen many instructors miss the opportunity to relate relations back to mathematics that you have already learned. That being said, I want to start off the discussion about relations with this. You already know relations. You just don't know that you know. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below and make sure to click on that subscribe button. Relations are the building blocks of mathematics. That's pretty controversial to say, but it's true. Relations are literally the tools in math that we use to relate two elements. For example, the equal symbol is a relation. It's a type of equivalence relation. Have you ever studied the equal symbol in full detail? Well, no. You just learned that the equal symbol means that the stuff on the left is the same as the stuff on the right. But what does that mean? I know that may seem like a silly question, but it can actually become pretty complex. We use the phrase equal all the time, and oftentimes we don't really mean equal. For example, we might say that 2 equals 1 plus 1. Let me draw a better one there. There we go. Which means that both 2 and 1 plus 1 are the same objects. However, in a different context, if we say that x is a variable, then x equals 2 carries an entirely different meaning. In this case, we claim that x and 2 are the same, but that actually defeats the point of x being a variable. Why do we call variables variables? Well, because they vary. They are meant to change. If we say that x equals 2, well then we are claiming that x and 2 are the same things. But 2 isn't a variable. The number 2 never changes. So then, is it true that x equals 2? Well, yes, because in this scenario, the equal symbol is used a little more loosely. This is where we introduce the concept of relations. Relations are anything that compares elements. For example, the less than symbol and the greater than symbol, the less than or equal to symbol, the greater than or equal to symbol, are relations because they're used to compare things. Technically, when you are talking about the coolest kid in the class, you can develop a new meaning for less than and greater than by saying that x is less than y, x is less than y, means that kid y is cooler than kid x. Relations are extremely fundamental in life, and so they deserve to be understood rigorously. So what exactly is a relation? Well, a relation, by definition, is a relationship between sets of values. In math, the relation is between the x values and the y values of ordered pairs. The set of all x values is called the domain, and the set of all y values is called the range. Now, this language might be familiar because you hear words like domain and range in the context of functions. That's because functions are a type of relation. However, we have an entire series of lectures dedicated to functions already. So if we were working with the most commonly used relation, the equal symbol, if we are trying to say that, for example, 2 equals 2, this would be written as 2, 2. So with the equal symbol relation, 3, 2 is not a part of that relation because 3 does not equal 2. With the less than symbol relation, and let me delete this real quick. With the less than symbol relation, 3, 2 is not a part of that relation because 3 is less than 2 is false. But, so that means that's not part of that relation, but 2, 3 is part of this relation because 2 is less than 3. Over the next few lectures, we'll be discussing the 2 major types of relations with technical definitions that you'll see in most discrete math courses: equivalence relations, or equal symbols, and ordered sets, or partial orderings, which makes use of the less than or equal to symbol. Anyways, thanks everyone, and I'll see you in the next video.